Hello, future LPTs. Welcome to your ultimate review channel for TLE and TVTE Majorship. We're here to guide you through essential concepts based on the MILKS K-12 curriculum, depth ed modules, and actual topics used by the PRC for the licensure examination for professional teachers. Whether you're preparing for the LET or just strengthening your foundation, this is the place to review, relearn, and refresh your knowledge in technology and livelihood education and technical and vocational teacher education. So don't forget to like, comment, and subscribe. And please click that bell so you never miss a review session. Now let's get started and take one step closer to becoming a licensed professional teacher. This is Let Review and Drills for September 2025, TLE and TVTE Majorship. Industrial Arts, Electronics Concepts. This is 50 items with rationalization, Part 8. So you may grab a piece of paper and a pen to answer. The correct answer will be shown right after each number. A 10 seconds timer is allotted. So make sure to answer all the questions honestly and do not hesitate to finish this video. So let's begin. First, disclaimer. No copyright infringement intended for educational purposes only. All the following questions found in this video belong to the rightful owner. So let's start. Number one, what is the color code for a 220 ohms 5% resistor? Is it letter A, red, red, brown, gold, B, orange, orange, black, gold, C, red, red, black, gold, D, red, red, brown, silver? Answer letter A, red, red, brown, gold. For red, red, brown, gold, according to color coding resistor, red for first digit, that's 2. Red for second digit or second band, that's 2. Brown for um, times 10 for multiplier, and gold for plus and minus 5% for tolerance. So total 22 times 10, that's 220 ohms plus and minus 5%. So answer letter A, red, red, brown, gold. For letter B, orange, orange, black, gold. Orange first band is equivalent to 3. Orange for second band, still 3. And black for multiplier, that's times 1. And 33 times 1, that's 33 ohms plus and minus 5%. So which is not the answer. For letter C, red, red, black, gold. Red, that's 2. Red for second band, that's 2. And black, that's times 1. So 22 times 1, that's 22 ohms plus and minus 5%. So still not the answer. And letter D, red, red, brown, silver. Red first band, 2. Red second band, 2. And brown, that's times 10. So 22 times 10, that's 220 ohms. But the value for silver, that's plus and minus 10%. So 220 ohms plus and minus 10% is not the answer. So final answer is letter A, red, red, brown, gold. Number 2, an atom's atomic number is determined by the number of A, neutrons minus protons, B, protons, C, electrons, D, neutrons. Answer letter B, protons. Protons, the atomic number is defined as the number of protons in an atom's nucleus. It determines the element, for example, hydrogen, that's equivalent to 1, and carbon for 6. Letter A, neutrons minus protons. This is incorrect as this gives the difference, not the atomic number. Letter C, still incorrect because atoms have the same number of electrons as protons, only when neutral. But atomic number is still based only on protons. And letter D, neutrons, incorrect. This is incorrect since neutrons determine the isotope, not the atomic number. So answer letter B, protons. Number 3, a voltage will influence current only if the circuit is A, open, B, insulated, C, high resistance, D, closed. Answer letter D, closed. A voltage or potential difference can only cause current to flow if there is a complete or closed path for the electrons to move through. This is called a closed circuit. Letter A, open. This is incorrect because in an open circuit, the path is broken, so no current flows, even if voltage is present. Letter B, insulated. Insulation prevents current flow. It does not allow voltage to influence current. And letter C, high resistance. This is partially related since high resistance will limit current but won't stop it entirely. So if the circuit is closed, still voltage can influence current in such a circuit. So answer letter D, closed. Number 4, which resistive component is designed to be temperature sensitive? Is it letter A, thermistor, B, rheostat, C, potentiometer, or letter D, photoconductive cell? Answer letter A, thermistor. A thermistor is a resistor whose resistance changes significantly with temperature. NTC, or negative temperature coefficient, resistance decreases as temperature increases. And PTC, or positive temperature coefficient, resistance increases as temperature increases. It is specifically designed to be temperature sensitive. For letter B, rheostat, this is incorrect because a rheostat is a variable resistor used to adjust current manually, not temperature sensitive. Letter C, potentiometer, still incorrect because a potentiometer is also a variable resistor. It is used to control voltage and is not temperature sensitive. And letter D, incorrect, photoconductive cell or photoresistor. This component changes resistance based on light, not temperature. So answer letter A, thermistor. Number 5, the battery symbol is letter A, ground, letter B, that's resistor, letter C, that's battery, and letter D, that's capacitor. So answer, that's of course letter C, battery. A source of electrical energy that provides a constant voltage. It consists of one or more electrochemical cells. So that's battery. For letter A, that's ground symbol, ground. When we say ground, it is a reference point in an electrical circuit from which voltages are measured. It provides a common return path for electric current and is often connected to the physical earth. For letter B, that's resistor. It is a component that resists the flow of electric current, producing a voltage drop. It is used to control current in circuits. And letter D, capacitor. It is a device that stores electrical energy in an electric field. It blocks DC while allowing AC to pass in filtering and timing circuits. So answer letter C. Number 6, primary batteries, unlike secondary batteries, may be A, charged once, B, used once, C, recharged over and over, or letter D, stored indefinitely. Answer letter B, used once. Primary batteries are non rechargeable batteries. Once they are discharged, they cannot be recharged and must be replaced. For letter A, charge once, primary batteries cannot be charged at all. Letter C, recharge over and over. This describes secondary batteries like lithium ion or um, NIMH. Letter D, stored indefinitely. While some primary batteries have a long shelf life, but they cannot be stored forever without degrading. So answer letter B, used once. Number 7, in practical applications, battery voltage A is restored as soon as disconnect occurs, B is lowered as the load increases, C may be stored indefinitely, or letter D will be reduced to zero as power is drawn. Answer letter B is lower as the load increases. When a battery supplies more current or higher load, its voltage tends to drop due to internal resistance and voltage drop inside the battery. For letter A, is restored as soon as disconnect occurs. This is generally not true because when a load is removed, the battery voltage may recover slightly, but it does not instantly restore to its full voltage because of internal resistance and chemical processes. Where letter C may be stored indefinitely, still not true for most batteries because batteries lose charge over time due to self discharge, so they cannot store voltage indefinitely. Letter D will be reduced to zero as power is drawn. Still not true because a battery's voltage decreases as it discharges, but it rarely reaches exactly 0 volts before being considered empty or unusable. Usually, the voltage drops below a usable threshold. So, answer letter B is lowered as the load increases. Number 8, if 60 J or joules of energy are available for every 15 C of charge, what is the voltage? A 4, B 60 volts, C 15 volts, D 0.25 volts. Answer letter A, 4 volts. To find the voltage, use the formula voltage equals E over Q, where V is that's voltage in volts, E that's energy in joules, and Q that's charge in coulombs. So let's substitute a value for E that's 60 joules and value for Q that's 15 charge. So substitute voltage equals 60 divided by 15, that's 4 voltage, which is letter A for voltage or for 4 volts. Number 9. The negative and positive charge symbols are assigned in that order to the A. Proton and electron, B. Electron and proton, C. Atom and nucleus, D. Electron and element. Answer letter B. Electron and proton. In physics and chemistry, the electron carries a negative charge and the proton carries a positive charge. This is a fundamental convention that helps us understand electric charge interactions, atomic structure, and the behavior of particles. The negative charge symbol is assigned to the electron, and the positive charge symbol is assigned to the proton. For letter A, proton and electron, this is incorrect because the proton actually carries a positive charge, not a negative one. The question specifies the order of negative, then positive. So, assigning the negative to the proton is wrong. Letter C, atom and nucleus. This is incorrect because an atom is the overall electrically neutral when balanced. Though it contains charged particles, the nucleus itself contains protons or the positive charge and the neutrons or neutral. But the atom itself is not simply assigned a positive or negative charge symbol. Letter D, electron and element. The electron has a negative charge, but the term element that refers to the type of atom, which is not specifically assigned a charge symbol in this context. So elements can have charged ions, but the question is about fundamental particles charges. So our answer is letter B, electron and proton. Number 10. A voltmeter is used A to measure current, B in series with the circuit, C in parallel with the circuit, or letter D to measure coulombs. Answer letter C in parallel with the circuit. A voltmeter is an instrument used to measure the voltage or electric potential difference across 2 points in a circuit. To do this accurately, it must be connected in parallel with the component or section of the circuit whose voltage you want to measure. This way, it measures the potential difference without significantly affecting the current flow. For letter A to measure current, this is incorrect because a voltmeter measures voltage, not current. An ammeter is used to measure current. Letter B in series with the circuit, still incorrect because connecting a voltmeter in series would disrupt the circuit and prevent correct voltage measurement. So voltmeters have very high resistance to avoid drawing current. So they are connected in parallel instead. And letter D to measure coulombs. This is incorrect because coulombs are units of electric charge. A coulomb meter or electrometer might measure charge, but a voltmeter measures voltage, not charge. So answer letter C in parallel with the circuit. Number 11, if the current in a circuit equals 0 amperes, it is likely that the A voltage is too high, B resistance is too low, C circuit has a short, D circuit is open. Answer letter D, circuit is open. If the circuit equals 0 amperes, 0 amperes, it most likely means that the circuit is open. meaning there is a break or gap somewhere in the circuit that prevents electricity from flowing. Since electric current needs a complete path to flow, an open circuit results in zero current. For letter A, a voltage is too high. This is incorrect because high voltage would typically increase current. That's according to Ohm's law, which is current equals voltage divided by resistance, unless the circuit is open. So high voltage alone doesn't cause zero current. For letter B, resistance is too low. Still incorrect because low resistance would cause more current, not zero. In fact, if resistance is zero, it would result in a short circuit and very high current, not zero. And letter C, circuit has a short. Still incorrect because a short circuit usually means there's little or no resistance, which causes excessive current, not zero current. So answer letter D, circuit is open. Number 12, current equals A columns over time, B columns times time, C voltage over time, or letter D voltage times time. Answer letter A, columns over time. Current is defined as the rate of flow of electric charge. In equation form, that's current equals charge or Q in columns divided by time or in seconds. For letter B, columns times time, this is incorrect because multiplying charge by time doesn't give current. It gives a quantity with incorrect units and no physical meaning in this context. For letter C, voltage over time, still incorrect because voltage divided by time doesn't represent current. The relationship involving voltage and current is given by Ohm's law, which is the I equals V over R, where R is the resistance. So still not the answer. Letter D, voltage times time, still incorrect because multiplying voltage by time also doesn't give current. So this product doesn't directly relate to current and has no standard meaning in basic electricity. So answer letter A, columns over time. Number 13, what are the unit and symbol for current? A ampere, letter A, letter B, coulomb, or letter I, letter C, ampere, letter Q, and or D, ampere, letter I. Answer letter A, ampere, that's letter A. The unit of electric current is the ampere and its symbol is A. An ampere measures the flow of electric charge per second, or that's 1 ampere, that's equivalent to 1 coulomb per second. Letter B, coulomb, that's I. Coulomb is the unit of electric charge, not current. Also, I is the symbol for current, not for charge. Letter C, ampere, or letter Q, still incorrect because ampere is the correct unit, but Q is the symbol for electric charge, not current. And letter D, ampere, that's letter I. So partially correct because I is the symbol for current that's used in equations, but the question asks for the unit and symbol. So the correct unit and symbol is A, not I. So answer letter A, ampere, A. Number 14, which part of an atom has no electrical charge? A, electron, B, neutron, C, proton, D, all of the above. Answer letter B, neutron. A neutron is a subatomic particle found in the nucleus of an atom. It has no electrical charge. It is neutral. This distinguishes it from the other subatomic particles. For letter A, electron, electrons carry a negative electrical charge, and protons carry a positive electrical charge. So answer letter B, neutron. Number 15, what type of switch is this? A, push button, B, SPST, C, DPDT, or letter D, SPDT. Answer SPDT. SPDT or single pole double throw switch has first one input terminal or single pole, then two output terminals or double throw, and it can connect the input to either of the two outputs, like used to switch between two circuits. For letter A, push button. So this is incorrect because a push button is momentary and usually SPST. So not used to toggle between two outputs. Letter B, SPST or single pole, single throw. No, it has one input and one output. So it simply turns a circuit on or off, not between two outputs. And letter C, DPDT or double pole double throw. It has two inputs and two sets of outputs, like having two SPDT switches in one. So answer letter D, SPDT or single pole double throw. Number 16, which voltage source converts chemical energy to electrical energy? A. Electrical generator. B. Battery. C. Solar cell. D. Electronic power supply. Answer letter B. Battery. A battery converts chemical energy into electrical energy through electrochemical reactions inside its cells. This is what allows it to supply power to electronic devices even when not plugged into a power source. Letter A, electrical generator. A generator converts mechanical energy into electrical energy, not chemical energy. Letter C, solar cell. A solar cell or photovoltaic cell, that's photovoltaic cell, it converts light energy or solar energy into electrical energy. And letter D, electronic power supply, still incorrect because this device modifies or regulates existing electrical energy, so often converting AC to DC, but it does not generate electricity from chemical energy. So answer letter B, battery. Number 17, if 40 C of charge flow past a point in 20 S, what is the current? A 2A, B zero point 0.5A, C 20A, or letter D 40A? Answer letter A, 2 amperes. Current I is calculated using the formula I equals QT, where Q is the charge in coulombs, T is the time in seconds, and I is the current in amperes, or letter A. So we have here given Q, that's 40 C or charge or in coulombs, T, that's 20 seconds. So I equals 40 divided by 20. So that's equivalent to 2 amperes. So which is letter A, 2 amperes. Number 18, batteries differ from fuel cells in that A battery is a closed system. B, a battery uses hydrogen and oxygen to create electricity. C, a battery uses a polymer electrolyte membrane. Or letter D, none of the above. Answer letter A battery is a closed system. A battery is a closed system, meaning all the reactants needed to generate electricity are stored internally. Once the chemical energy is used up, the battery must be replaced or recharged. In contrast, a fuel cell is an open system. It requires a constant external supply of fuel like hydrogen and an oxidant like oxygen to continue producing electricity. For letter B, a battery uses hydrogen and oxygen to create electricity. This is incorrect because this describes a fuel cell, not a battery. Letter C, a battery uses a polymer electrolyte membrane. Still incorrect because a polymer electrolyte membrane or PEM, is specific to PEM fuel cells, not typical batteries. So answer letter A battery is a closed system. Number 19, the removal of a non-neutral subatomic particle converts the atom into A charged ion, B nucleus, C heavier element, D compound. Answer letter A charged ion. When a neutral subatomic particle, like an electron or proton, is removed from an atom, the atom becomes a charged ion. If an electron is removed, the atom becomes a positive ion or cation. If an electron is added, it becomes a negative ion or anion. This change creates an imbalance in the number of protons and electrons, resulting in a net electrical charge. For letter B, nucleus, this is incorrect because the nucleus is the central part of an atom. But removing a particle doesn't convert the atom into just a nucleus unless all electrons are stripped, which is not the question describes. Letter C, heavier element, still incorrect because changing the element requires changing the number of protons, not just removing a subatomic particle. Also, removing something doesn't make it heavier. And letter D, compound, still incorrect because a compound is formed when atoms bond with other atoms, not by removing subatomic particles from a single atom. So answer letter A, charged ion. For 20, one column passing a point in 1 second is 1 A ampere, B volt, C ohm, D charge. Answer letter A ampere. An ampere is the unit of electric current and it's defined as one coulomb of charge passing a point per second. Or mathematically, that's 1 ampere equals 1 coulombs per 1 second. So if 1 coulomb passes a point in 1 second, the current is exactly 1 ampere. For letter B, volt. A volt is a unit of electric potential voltage, not current. Letter C, ohm, it is the unit of electrical resistance. And letter D, charge. Charge is measured in coulombs, not in coulombs per second. So the question is asking for the unit of current, not charge. So answer letter A, ampere. Number 21, in which states may matter may be found? A, solid, liquid, or mineral. B, solid, gas, or liquid. C, mineral, gas, or liquid. Or letter D, plastic, solid, or gas. Answer letter B, solid, gas, or liquid. Matter commonly exists in three primary states. So we have solid, liquid, and gas. For solid, that's definite shape and volume. For liquid, that's definite volume but no fixed shape. So it takes shape of container. For gas, it has no fixed shape or volume, so it expands to fill container. These are the fundamental states of matter most often studied. For letter A, solid, liquid, or mineral. Mineral is a type of solid substance, but not a state of matter. For letter C, mineral, gas, or liquid. No, that's the same. So mineral is not a state of matter. Letter D, plastic, solid, or gas. Plastic is a material, so not a state of matter. So answer letter B, solid, gas, or liquid. Number 22, the material that consists of a mixture of elements is considered to be A, an element, B, an ion, C, a compound, or letter D, a molecule. Answer letter C, a compound. A compound is a material made up of two or more different elements chemically combined in fixed proportions. Compounds have properties different from the individual elements that compose them. For letter A, an element, this is incorrect because an element consists of only one type of atom, not a mixture of elements. For letter B, an ion, still incorrect because an ion is an atom or molecule that has gained or lost electrons and carries an electric charge, not necessarily a mixture of elements. And letter D, a molecule, partially correct but incomplete because a molecule can be made of the same element like O2 or oxygen or different elements like H2O or like the water. But the question emphasizes a mixture of elements, so the broader term compound is more accurate. So answer letter C, compound. Number 23, an example of potential energy is A, tea kettle steam, B, a moving vehicle, C, the sun, or letter D, a battery. Answer letter D, a battery. A battery stores chemical potential energy that can be converted into electrical energy when connected in a circuit. This stored energy is available for future use, which is the key feature of potential energy. It is energy that is stored due to position or condition. For letter A, T keto steam, this is incorrect because steam is an example of thermal energy or heat energy, not potential energy. For letter B, a moving vehicle, still incorrect because a moving object has kinetic energy, not potential energy. And letter C, the sun, still incorrect because the sun produces nuclear and radiant energy, not potential energy in this context. So answer letter D, battery. Number 24, how many valence shell electrons are there in semiconductor atoms? A 16, B 8, C 4, D 2. Answer letter C 4. Semiconductor atoms such as silicon and germanium have four valence electrons in their outermost shell. So these four electrons allow them to form covalent bonds with other atoms, which is crucial for their semiconducting properties. So answer letter C, 4. Number 25, when considering conventional current versus electron current flow, A electron current flow came first, B protons move in conventional current flow, C conventional current flow came first, D the direction of current is the same in both methods. Answer letter C, conventional current flow came first. Conventional current flow was defined historically as the flow of positive charge from positive to negative terminal before electrons were discovered. Later, it was found that the electrons actually flow in the opposite direction from negative to positive terminal. Despite this, the original convention remains in use. For letter A, electron current flow came first. This is incorrect because conventional current flow was established first before the discovery of electrons. Letter B, protons move in conventional current flow. Still incorrect because protons do not move in typical circuits. Electrons are the actual charge carriers in conductive materials. And letter D, the direction of current is the same in both methods. Still incorrect because the directions are opposite. Like conventional current assumes positive charge flow, electron current is the actual flow of electrons in the opposite direction. So, our answer here is letter C, conventional current flow came first. Number 26, which unit of charge contains 6.25 times 1018 electrons? Is it letter A, an ampere, B, a coulomb, C, a volt, or letter D, a joule? Answer letter B, a coulomb. A coulomb is the unit of electric charge and is defined as the charge of approximately 6.25 by 10 raised to the power of 18 electrons. Each electron carries a charge of about 1.6 times 10 minus 19 or negative 1.6 times. That's 10 raised to the power of negative 19 minus or negative, that's 1.6 by or times 10 minus 19 columns. So multiplying this by the number of electrons gives one column. For letter A, an ampere, this is incorrect because an ampere is the unit of electric current, not charge. Still incorrect is letter C, a volt, because a volt measures electric potential difference. And incorrect, letter D, a joule, because joule measures energy. So answer letter B, a coulomb. Number 27, a switch is a device that A short circuits complex circuits, B holds a fuse, C has double poles, D opens for completes a current path. Answer letter D, opens or completes a current path. A switch is an electrical device used to open or break or close or complete an electrical circuit, thereby controlling the flow of current. When the switch is open, current cannot flow, but when it is closed, current flows through the circuit. For letter A, short circuits complex circuits A switch does not create short circuits. So, short circuits are faults that cause unintended low resistance paths. Letter B holds a fuse. A fuse is a separate protective device. So, switches do not hold fuses. And letter C has double poles. Some switches have double poles, but not at all. So this is a specific type of switch like the DPST or DPDT, not a general definition. So answer letter D opens or completes as current path. Number 28, the term used to designate electrical pressure is A voltage, B current, C resistance, D conductance. Answer letter A voltage. A voltage is a term used to describe electrical pressure or electrical potential difference that pushes electric charges through a circuit. It is measured in volts. For letter B current, current is the flow of electric charge. So not the pressure causing it. Letter C resistance. Resistance opposes the flow of current in a circuit. And letter D conductance. It is the measure of how easily current flows. That's the reciprocal of resistance. So answer letter A voltage. Number 29. Which electronics material opposes the movement of free electrons? A conductor, B insulator, C semiconductor, or letter D element. Answer letter B insulator. An insulator is a material that strongly opposes the movement of free electrons. So that's preventing the flow of electric current. So examples include rubber, glass, and plastic. Insulators have very high electrical resistance. For letter A, conductor. Conductors allow free electrons to move easily, enabling electric current flow. Letter C, semiconductor. Semiconductors have moderate resistance, so they can conduct electricity under certain conditions. And letter D, element. An element is a type of substance, so not specifically related to its ability to conduct or resist electron flow. So answer letter B, insulator. Number 30, current is considered as the movement of A electrons, B protons, C charge, or D nuclei. Answer letter C, charge. Current is the flow of or movement of electric charge through a conductor. While in most circuits, this charge is carried by electrons. Current is more generally defined as the movement of any charged particles. For letter A, electrons, this is partially correct because in typical conductors like metals, electrons are the charge carriers, but current as a concept refers broadly to charge flow. Or letter B, protons. Still incorrect because protons are bound within an atomic nuclei and do not move through circuits. And letter D, nuclei. Still incorrect because atomic nuclei are stationary in solids and do not move as part of electric current. So answer letter C, charge. Number 31. A lead acid battery is an example of A. Solar cell, B. Fuel cell, C. Primary battery, or letter D. Secondary battery. Answer letter D, secondary battery. A lead acid battery is a type of secondary battery, meaning it can be recharged and used multiple times. It converts chemical energy to electrical energy during discharge and can be restored by applying electrical energy during charging. For letter A, solar cell, a solar cell converts light energy directly into electrical energy. For letter B, fuel cell, it generates electricity continuously from external fuel and oxygen, unlike a battery which contains its reactants internally. And letter C, primary battery. These are used once and cannot be recharged, unlike lead acid batteries. So answer letter D, secondary battery. Number 32, the charge of one coulomb is equal to A 6.24 by 10 negative 18 electrons, B 1 ampere, C 1 second, D 6.24 by 1018 electrons. Answer letter D 6.24 by 1018 electrons. A one coulomb is the amount of electric charge carried by approximately 6.24 by 18 raised to the power of 18. Oh, so that's 10 raised to the power of 18. It's not 1018, to be clear. Each electron carries a very small charge, like that one. So it takes that many electrons to make up one coulomb. So answer letter D. Number 33, a basic electric circuit is made up of what components? Is it letter A, a load, a resistor, and a conductive path for current? B, a voltage source, a load, and a conductive path for current? Letter C, a voltage source, a conductive path for current, and a battery? Or letter D, a conductive path for current, a battery, and a copper wire? Answer letter B, a voltage source, a load, and a conductive path for current. So a basic electric circuit consists of a voltage source like a battery that provides electrical energy, a load such as a lamp or motor that uses the electrical energy, and a conductive path or wires that allows current to flow between the voltage source and the load, completing the circuit. So answer letter B. Number 34, an ammeter is used to measure A, voltage, B, current, C, resistance, D, all of the above. Answer letter B, current. An ammeter is an instrument specifically designed to measure electric current flowing through a circuit. It is connected in series with a circuit to accurately measure the current. For letter A, voltage, it is a it's measured using a voltmeter. For resistance, it is measured using an ohmmeter or a multimeter to set the resistance mode. So answer letter B, current. Number 35, what is the name of the pressure that moves electrons in a closed circuit? Is it letter A, amperes, B, ohms, C, voltage, D, coulombs? Answer letter C, voltage. Voltage is the electrical pressure or potential difference that pushes electrons through a closed circuit. It provides the energy needed for current to flow. For letter A, amperes, it measures current, so which is the flow of electrons. For ohms, it measures resistance. And for coulombs, it measures electric charge, so not pressure. So answer letter C, voltage. Number 36, what is a characteristic of a secondary cell? A, rechargeability. B, not rechargeable. C, a dry cell. D, non-liquid. Answer letter A, rechargeability. A secondary cell is a type of battery that can be recharged and used multiple times. Unlike primary cells, secondary cells can restore their chemical energy by applying an external electrical current. For letter B, not rechargeable, this describes primary cells. For letter C, a dry cells. It can be either primary or secondary. Being dry refers to the electrolyte state, not rechargeability. And letter D, non-liquid. Electrolytes in secondary cells can be liquid, gel, or solid. So this doesn't define the characteristic of rechargeability. So answer letter A, rechargeability. Number 37. What are the basic building blocks that all matter is composed of? A, electrons, neutrons, and protons. B, two protons for each neutron. C, two protons for each electron. Letter D, electrons, neutrons, and charged ions. Answer letter A, electrons, neutrons, and protons. So all matter is fundamentally made of atoms, which consists of three basic building blocks. First, protons. These are the positively charged particles in the nucleus. Second, the neutrons. That's neutral particles in the nucleus. And electrons. That's negatively charged particles orbiting the nucleus. So answer letter A, electrons, neutrons, and protons. Number 38. If a fluid system is compared to an electrical system, the fluid pump will correspond to A, letter A, conductor, B, lamp, C, battery, D, insulator. Answer letter C, battery. In an analogy between a fluid system and an electrical system, the fluid pump corresponds to a battery because both provide the energy or the pressure or voltage needed to move the flow in fluids. It's pressure pushing the liquid. In electricity, it's voltage pushing electrons through a circuit. For letter A, conductor, this is incorrect because a conductor allows flow but doesn't provide the driving energy like a pump or battery. For letter B, lamp, still incorrect because a lamp is a load that uses electrical energy, so it doesn't supply energy. And letter D, insulator, still incorrect because an insulator restricts flow, so that's the opposite of what a pump or battery does. So answer letter C, battery. Number 38, an element is a substance that is A, varied throughout the entire piece, B, used only in electronics, C, electrically charged, D, found only in its pure form. Answer letter A, varied throughout the entire piece. An element is a pure substance made of only one type of atom, and it is uniform or consistent throughout the entire piece. This means its composition does not vary in different parts of the material. For letter B, used only in electronics, elements are found everywhere, so not just in electronics. Letter C, electrically charged. This is incorrect because elements themselves are neutral substances, though they contain charged particles. And letter D, found only in its pure form. Still incorrect because elements can be found in compounds and mixtures, not only in pure form. So answer letter A, varied throughout the entire piece. Number 40, current is A, the presence of a positive charge, B, the abundance of electrons, C, the movement of electrons, or letter D, the repulsion of electrons. Answer letter C, the movement of electrons. So current is defined as the flow of movement or electrons or electric charge through a conductor. This flow is what allows electrical energy to be transferred in a circuit. For letter A, the presence of a positive charge. Current is about charge movement, so not just the presence of positive charge. Letter B, the abundance of electrons. Having many electrons doesn't create current unless they move. And letter D, the repulsion of electrons. While electrons repel each other, current specifically refers to their movement, not just repulsion. So the answer here is the movement of electrons. So that's current. Number 41, what do you call a diagram that shows the electrical connections of a circuit's components? Is it letter A, a schematic diagram, B, a pictorial diagram, C, a block diagram, or letter D, an electrical diagram? Answer letter A, a schematic diagram. A schematic diagram is a type of drawing that uses standard electrical symbols to show the electrical connections and functions of a circuit's components. It focuses on the logic and layout of the circuit, so not the physical appearance. For letter B, a pictorial diagram, so it shows components as they physically appear, which is more for visualization than for technical use. For letter C, a block diagram, it shows high level system functions or modules using blocks. Letter D, an electrical diagram. This is partially correct but too vague. While electrical diagram can refer to many types of diagrams, like the schematic diagram, no, like for specific. So correct term for detailed connection layout. Yes, that's schematic diagram, which is letter A. Number 42, a short circuit will have a small current flow, B, a large current flow, C, no current flow, or letter D, some current flow. Answer letter B, a large current flow. A short circuit occurs when electricity flows along an unintended low resistance path because resistance is so low. A very large current flows, which can lead to overheating, damage, or even fires if not properly protected. For letter A, a small current flow. A short circuit causes a surge in current, so not a reduction. Letter C, no current flow. That would describe an open circuit, so not a short circuit. Letter D, some current flow. while technically true, but it's too vague. So the key characteristic of a short circuit is that the current is excessively large, which is letter B, a large current flow. Number 43, the basic difference between a fuse and a circuit breaker is it letter A, a fuse is slower, B, a fuse is reusable, C, a circuit breaker is reusable, or letter D, a circuit breaker is more reliable. Answer letter C, a circuit breaker is reusable. So the basic difference is that a circuit breaker can be reset and reused after it trips due to overcurrent, while a fuse must be replaced after it blows. This makes circuit breakers are more convenient for long-term use and maintenance. For letter A, a fuse is slower. This is incorrect because fuses typically react faster than circuit breakers. Letter B, a fuse is reusable. Still incorrect because fuses are single use devices. Once blown, they must be replaced. And letter D, a circuit breaker is more reliable. Still incorrect because both can be reliable when used appropriately. Reusability, not reliability, is the key difference. So, just the answer here is letter C, a circuit breaker is reusable. Number 44, which is the smallest? A, atom, B, proton, C, neutron, or letter D, electron? Answer letter D, electron. The electron is the smallest in both mass and size among the listed particles. So it is a subatomic particle with a negative charge and is much smaller than protons, neutrons, and atoms. To compare for electron mass, you can read that. And for proton or neutron mass, and then the atom. No? So atom is composed of all three particles and is vastly larger in size than electron, proton, and neutron mass. So answer letter D, electron. Number 45. A secondary cell generates DC via chemical activity. A primary cell generates DC via, is it letter A, electrically, B, thermally, C, optically, or letter D, chemically? Answer letter D, chemically. Both primary and secondary cells generate direct current through chemical reactions. A primary cell produces DC or direct current chemically and is not rechargeable. So, for example, alkaline batteries. And a secondary cell also uses chemical activity but can be recharged. For example, lead acid or lithium ion batteries. So, answer letter D, chemically. Number 46. Which of the following statements is true? Is it letter A, unlike charges repel and like charges attract? B, like charges repel and unlike charges attract? C, unlike charges attract and like charges attract? Or letter D, like charges repel and unlike charges repel? Answer letter B, like charges repel and unlike charges attract. So this is the fundamental principle of electrostatics. Like charges, positive, positive, or negative, negative, repel each other. Unlike charges, positive, negative, attract each other. This rule governs how charged particles behave in electric fields and is key to understanding atomic structure and electrical forces. So answer letter B, like charges repel and unlike charges attract. Number 47, if an electrical system is compared to a fluid system, the electrical current corresponds to the A pressure, B pump, C water wheel, D water flow. Answer letter D water flow. In a fluid electric analogy, electrical current that's measured in amperes corresponds to the flow of water or water flow in a pipe. Just as water flow represents the movement of fluid through a system, so current represents the flow of electric charge through a circuit. For letter A, pressure, this is incorrect because pressure in a fluid system is like voltage in an electrical system as it pushes the flow. Letter B, pump. A pump adds energy like a battery or voltage source to the drive flow. To drive the flow. And letter C, water wheel. Still incorrect because a water wheel would be comparable to a load. So like a motor or light that uses the energy in the flow. So answer letter D, water flow. Number 48, what is the product over sum result of 150 and 6,800? Is it letter A 150, B 146.7, letter C 0.006, or letter D 6,800? Answer letter B for 146.7 because the product over sum formula is often used to calculate the equivalent resistance of two resistors in parallel. So this is the formula. Resistors in total, that's R1 times R2 over R1 plus R2. So for 150 and 6,800, so that's 150 times 6,800 divided by 150 plus 6,800. So 150 times 6,800, that's 1,020,000. And for 150 plus 6,800, that's 6,950. So 1,020,000 divided by 6,950, that's 146.76 or 1.46.7, letter P. Number 49, when parallel resistors are of three different values, which has the greatest power loss? Is it letter A, the smallest resistance, B, the largest resistance, C, they have the same power loss, or letter D, the voltage and resistance values are needed? Answer letter A, the smallest resistance. In a parallel circuit, all resistors have the same voltage across them. The power loss in each resistor is given by power equals voltage raised to the power 2 times resistance. Since voltage is constant and resistance varies, the smaller the resistance, the greater the power loss because you're dividing a smaller number. So the answer letter A, the smallest resistance. For letter B, the largest resistance, this is incorrect because a larger resistance results in lower power loss in a parallel circuit. And letter C, still incorrect. They have the same power loss. Only true if all resistors have the same resistance, which the question says they do not. So still incorrect. And letter D, incorrect. Voltage and resistance values are needed. While exact values are needed for exact power numbers, the relationship between resistance and power loss in parallel makes this answer unnecessary for a relative comparison. So that's why our answer is letter A, the smallest resistance. And last, number 50, the voltage across any branch of a parallel circuit A varies as the total current varies. B is inversely proportional to total circuit resistance. C is equally applied to all branch conductances. Or letter D is dropped in proportion to each branch resistance. Answer letter C is equally applied to all branch conductances. In a parallel circuit, the voltage across each branch is the same as the voltage of the power source, regardless of the resistance or conductance of the individual branches. This is a defining feature of parallel circuits. For letter A varies as the total current varies. This is incorrect because voltage across each branch stays the same. So it does not vary with current in parallel. Where letter B is inversely proportional to total circuit resistance. This is still incorrect because voltage is set by the source. This statement confuses total circuit behavior with branch behavior. And letter D is dropped in proportion to each branch resistance. Still incorrect because that describes series circuits, not parallel circuits. So answer letter C is equally applied to all branch conductances. Okay, that ends our 50 items. Okay, so how many correct answers did you get? Okay, so please comment your scores in the comment section. So I hope you got a passing score of 38 and above. And also, please, I'll ask you a favor to subscribe or follow our Facebook page, TLE or TVTE Reviewers. The same with our YouTube channel. So that's it for today's TLE and TVT review session. So I hope you learned something new and valuable to help you prepare for the LET. So if this video helped you, don't forget to like, share, and yes, subscribe for more helpful review content. So if you have questions or topics you want us to cover, please drop them or type in the comments below. So I would like you to remember that consistency and faith go a long way in your journey to becoming a licensed professional teacher. So for James chapter 1 verse 5, so if any of you lacks wisdom, you should ask God, who gives generously to all without finding fault, and it will be given to you. So that's it for today's. See you in the next video and good luck future LPT. God bless you.